Hello, cluster receiving students and teachers. Maybe all seated. Other class receiving students and teachers, I'd like to welcome you back to Term 2, Grade 8 Science. I hope what we will go through this term, students in the receiving schools and teachers as well, you will learn as much as you can. And what we teach you, it should help you in your schoolwork for this term. Now, this term we will be looking at, especially teachers, the strand Science in the Home. Now in this strand, this is a new strand, and we will be also having or going through 2 outcomes. Now, our sub-strand for the 2 outcomes is on learning about substances. First outcome, 8.3.1, it says conduct investigation and use collected data to identify patterns in the physical interactions of substances. Now in this outcome, we have the unit title, which is patterns in the physical interactions of substances. Our second outcome is 8.3.2. Identify and collect basic and acidic substances found in nature and use this data to elaborate on how this can be used to benefit the community. The unit title for this outcome is Finding Useful Acidic and Basic Substances in Nature to Benefit the Community. Now, class and the receiving students, in the previous lesson, last term, in term 1, you finished off with awareness on non-biodegradable materials, the uses and the effects. Now, I would like Fiona, if you can give us the answer to the first question, and also our receiving students, you give the answer for the first question to your teacher, and others can also get ready for the answer to the second question. What are non-biodegradable materials, Fiona?
Non-biodegradable materials cannot decay.
Materials that cannot decay, thank you. I hope our receiving students, you also try to give an answer similar to that as Fiona's. How do non-biodegradable materials affect the food web? Let's have Yoa, please.
It affects by
You have looked at food web, food chain. Now, how do non-biodegradable materials affect the food web? Can we have someone from the same group as Yoa to help him with answer for the question? Receiving students, I hope you're already giving your teacher the answer to that question. Okay, thank you. Let's have Eddie.
Chemical is an example of non-biodegradable material. If people dump chemical in water, it will affect fish because fish lives in the water.
How does it affect fish? How does it do that, Eddie?
When fish breathe in the water, it will affect from breathing.
Thank you, Eddie. Now, our topic for our first lesson for the strand Science in the Home, substrand learning about substances, is on we are particles. We are particles. Now, before we look at in the about matters in grade 7. Now, if I can have someone from the class as well as the receiving students to give your teachers and the class to give me what you know of matters. Thank you. Let's have you.
Matter is anything that has volume and takes up space.
Very good, thank you. Okay, so matter is anything, as she has said, that has mass and takes up space. Now, example, I have these two. Okay, this is a matter. This piece of wood is a matter. It has mass. I also have this flask of water. This is a matter too, and also it has mass and it takes up space. So these are just two examples to show you what matter is. All living and non-living things are made of matter. You are made of matter too. Anything, the tables that you have in the classroom, books you are using, everything is made of matter. All matter is made up of tiny particles. Tiny particles. Anybody from the class who can tell us what you know of particles? Receiving students, please let your teacher know what you know of particles. What are particles? Anyone from the class? Okay, let's see what I have. Particles are pieces of matter that make up a substance which cannot be seen through a microscope. Just like you have seen in the picture of, I had a diagram there on the topic, we are particles. Particles look like that, and they make up the substance or the matter. I hope you also looked at 3 states of matter, the 3 common states of matter in grade 7. So if I can have someone from the class as well as the receiving students, tell your teachers. Let's have Nancy.
Solid, liquid, and gas.
Good. Solid, liquid, and gas. Those are the common states of matter. You will look more at that in the next lesson. Now we have activity for every one of us to do, as well as the receiving students. Teachers, I'd like you to take note of each of those activities. These are the activities that the students are going to be doing. And I believe you don't have the Term 2 books with you, so please take note of the activities that we are going to go through. Now, students, I also want you to take note of what we are going to go through. If you are in group 1, 2, and 3, you're going to do a role play of how particles behave in solids, liquids, and gases. Now, after the instruction, I will go through briefly on solids, liquids, and gases and how they behave, and I'd like you to take note also of that. Groups 1, 2, and 3, that is what you are going to do. 1, you are going to be doing a role play on solids, 2 on liquids, and 3 on gas. Now groups 4, 5, and 6, you will be drawing a diagram of the arrangement of particles in solids, liquids, and gas. 4 solids, 5 liquids, and 6 gas. Now the instruction further says Individually, you are going to draw on a separate piece of paper. You will be all given a piece of paper like this. Now, on that piece of paper, you draw the arrangement of each of the particles in those different states of matter. And after that, you are going to glue onto a large sheet of paper. 7, 8, and 9, you are going to describe how these particles behave in solids, liquids, and gases. 7, solids, 8, group 8, liquids, and group 9, gases. Take note as we go through quickly on how particles in different states of matter behave. Solid, you must all be packed tightly since the particles in a solid are firmly held together. You need to hold each other on the shoulder. Teachers, please take note of what we have on the screen when we go through the other, before we go through the other part of solids. The particles in a solid vibrate but cannot change positions because the attractions are too strong. Those who are doing a role play, you have to move to and fro without leaving your place. I hope you have taken note of what we have just gone through from the first slide to the next one. Liquid, take note of that, the groups that are working on liquids, the teachers too in the receiving schools. You must all be packed loosely. You can slide by each other, but stay loosely close together. Now we continue with more on liquid. The particles in a liquid vibrate and can change positions. Now we know that in liquid they can't change positions, but in liquid they can. This is because the attractions are not so strong and they all have to be loosely packed, not tightly packed as in liquids. Sorry, in solids. Teachers, I hope you are taking note of all that. Now, the last state of matter we have is gas. Gas says you must all move freely at high speed and straight all around the room and must be far apart. You can bump each other or bump with the wall of the room and change your direction. Now, this is relating to the role play, but when we look at that, this is actually telling us how the particles in gas behave. When it says room, this is actually talking about a container that may contain gas in it, and that's how it behaves. Here it says bumps. We can also say collide. The particles, they collide or bump onto each other. Now we still have more on gas. This is about the particles. In a gas, they have to move freely at high speed because the attractions are very weak. Now, where the attractions are very strong, the particles are not able to move away from each other. Where the attraction is very weak, they are able to move away from each other. Now, teachers are in the receiving schools with your students. We will be going through the activity where we will have groups 1, 2, and 3. You all already know that we have 9 groups in our model class. So each group will be doing different activities. The class, you are all aware of what you are going to be doing. So groups 1, 2, and 3, if I can have your runner to come and get your guideline to help you to do your role play. Now listen, groups 1, 2, and 3, we don't have space in the room, so you are going to go out to the car park and you look through the guideline and rehearse. You practice how particles behave in each of those states of matter. So if I can have the runners, please, from each group, 1, 2, and 3, solid, solid. Group 1, solid. Group 2, liquids. You can move out now to the car park. Group 1, which is group 1 here? Oh, you are group 1, is it? Okay, if I can have group 1, 2, and 3 move out. Quickly. Four, 5, and 6. 4, 5, and 6, if I can have the runners. Just now 7, 8, and 9. You're not going to be given any guidelines. You have looked through what we went through. So in your group, you are going to discuss and describe how solids, liquids, and gases behave. If I can have the runners to come and get your papers. Now listen, you are given 5 minutes to do that activity. Group 4, 5, and 6. 7, 8, and 9, you are given 5 minutes to do that activity that I've just given you a short while ago. You have been given a piece of paper, listen. Now, because I didn't like everyone to, especially group 4, 5, and 6, you just sit around and wait for one person to do it, okay? So you are all going to talk about how the particles are arranged, and you will all draw. Like you may draw part of it, you draw it, and then you glue them together and it becomes one. See? Can you get what I see? You draw. So instead of you waiting for one person to draw it all over this paper, that takes time. So you're all going to draw your particles. You draw. After that, you put it together, and it becomes 1. So instead of all of you just sitting down and one person drawing how particles are arranged in liquids, all of you will draw. You draw part of it here, and then after that you glue all of them together, so it becomes 1. So example, if your particle you think that it's far apart, okay, that's yours now. How particles are arranged in gas. Now, in one of the state of matter, the particles are close together. In another state of matter, the particles could be something like that. In another, the particles are far apart. Now, which one is yours? Which one is your particle? Okay, so you have yours. Jean is going to draw her particles. You draw yours on the piece of paper. After that, you bring them, stick them on. You see. If I can have 7, 8, and 9 to listen, yours is on description of how particles behave in each of those 3 states of matter. Okay, you are doing a solid, liquid, and gas. I've just gone through the instruction on how your friends are going to do the role play, so that should have helped you to know how particles in solids behave, how particles in liquids and in gases behave. Then you discuss it together, and somebody writes, the recorder will write what you are going to discuss together on the paper, and that's all. It's a simple activity for you to do. Now, so how do particles in solids behave? When they're loose, very far apart, or just loose? Just loose, okay? What else? Okay, that's 1. They are loose, what else? Cannot move, that's solids. Solids, they can't move. The particles don't move. Because the attraction is strong, they can move. Narapla like move, narapla pulimem come back. But in a liquid, they can move. Very fast. Okay. So how do they behave? Because it's weak, what happens to the particles? They move freely, okay. What else? Good. Very loose or just loose? You said loose. Now, very loose or just loose? Very loose. What else? How do they move? Yeah, they move at a... Yeah, okay, that's the description. So you have that written here. See? Listen, groups 4, 5, 6, 7, 8, 9. Once you finish, I'd like you to have your work put up on the whiteboard, okay? The diagram above and the description below the diagram. We have the first group from liquid. They have the diagram up. Please, the others, start bringing yours in. The description goes under each of those diagrams, the arrangement of particles in each of those states. You can just fill part of the paper. That's okay. Descriptions, Graham, finish, or still writing? Your friends who are doing a role play, they're waiting for you. Once you finish, they will come in. Here, you got 3 there. 3 magnets there for you. And then one at the bottom. Thank you. Good. Good. We have gas already up. The arrangement of the particles as well as the description. Thank you. We have the liquid going up. Now listen, I want to have one person from each group. Okay, one from solid, one from liquid, and one from gas. You're going to explain to your friends in the class and the receiving students about the arrangement of the particles in each of those states, as well as the description of it. So if I can have the 2 groups who did solid, 2 groups who did liquid, and 2 that did gas, you pick someone so that person can come and present what you have done. Receiving students and teachers, we've just done those 3 activities, and I will have 3 students, 1 on solid, 1 liquid, and 1 gas. Now, each of these students are going to come up and explain to us on the diagram they've drawn of the arrangement of solids, liquids, and gases, and describe them. And we will also see our friends who have done the role play too as well. So if I can have the student who is presenting solids.
Okay, this is a diagram showing how particles in solid are arranged. Okay, here is a brief description on how particles behave in solids. Particles in solids are held tightly together, vibrate against each other, and cannot hold positions because the attraction is too strong.
Very good. Thank you, Natasha. Now we'll look at the role play of particles in a solid.
Solids. The particles in a solid vibrate but cannot change positions. Because the attractions are too strong, move to and fro without leaving your place. You must all be packed tightly. Since the particles in a solid are firmly held together, you need to hold each other on the shoulder.
Okay, we'll have our presenter for liquids, please. Liquids.
Okay, here's a description of how particles in liquid are arranged. The particles are loose, can move freely but slowly because the attraction is not very strong. And this is how the particles are arranged. So you can see.
Can you tell us the difference from solids to liquids, especially the arrangement?
Solid, they are held tightly together, and the liquid is held like they're loose.
Loose. Very good. Thank you, Rose. Okay, we have a look at our role play on liquids.
The particles are loose, can move freely but slowly because the attraction is not very strong.
We have our last presenter, please, for gas.
This picture shows the particles in gas, how they arrange. Here is a small description of particles in gas. The particles in gas move very freely at high speed and the attraction is very weak.
How can you tell us of the weakness of the attraction on the diagram that you have, that arrangement? You have the diagram up there. How is it shown there? They are very weak up there.
They are spaced very far apart.
Very good. Thank you. The spaces are far apart. Thank you. Good. We'll have a look at the role play on gas.
Gas. You must all move freely at high speed and straight all around the room and must be far apart. You can bump each other or bump with the wall of the room and change your direction. The particles in a gas move freely at high speed because the attractions are very weak.
Now the summary for our lesson for today. All matter is made up of particles. Please take note of that quickly, students, in both the model class and the receiving classes. All particles in a substance are the same. Three different substances are made up of different particles. For there are different forces amongst particles. These attractions may be strong or weak. When the attractions are strong, the particles are held tightly together, like in solids. When they are weak, they are loose or far apart, like in liquids and gas. There are also spaces among the particles. When the attractions are not strong, they are weak, there are spaces there too. Our last summary point. The particles are always moving, The more energy the particles gain, the faster they move. Christy, a keyword for this lesson, a keyword. You can give us what the keyword should be. Mike?
Particles.
Particles. Good, thank you. A keyword is particles. Now, next lesson, teachers, and the students, it's going to be on everything matters. Everything matters. Now, in this lesson, you will need a lot of things. Please, I'd like you to take note of that, teachers. We have the list of things there. I'm not going to go through them, but I'd like you to see them and take note of everything that is needed for the next lesson. And with that, thank you all for your participation.